So, today we are going to discuss about knapsack problem using Fifo branch and bound solution. So here a knapsack is a problem of filling n number of items in a knapsack so that we will earn a profit. So here knapsack means a bag. The constraint to fill the items is a knapsack is having a capacity so that we will not cross that capacity. This knapsack problem is solved using branch and bound technique, and in this two branch and bound techniques are there. One is LC branch and bound, another one is FIFO branch and bound. Here the branch and bound technique deals with only minimization problems. Here knapsack is the objective function is achieve maximum profit, so that before start the problem all the profits will be converted into the negative values. Then only you may start the problem. So whether LIFO branch and bound technique or FIFO branch and bound technique, we need to calculate lower bound and upper bound. Lower bound, this is a upper bound. So while calculating upper bound, fractional items are not allowed. Fractionals are not allowed. So that you are able to place the entire item, or you may not place the item. But fraction of items are not allowed to place into the knapsack. And C of X is a lower bound. Here fractionals are allowed while placing the items into the bag. So these are the constraints while calculating profits and placing the items. So today we discuss about FIFO branch and bound technique, knapsack problem. So we will take one example. Here n is equal to 4. That means four items are there, and profits, that means P1, P2, P3, P4. Profits for 4 items is equal to 10, 10, 12, 18. These are the profits. And weight, two, 4, 6, 9. So the weight of first item is 2 kgs, and the weight of second item is 4 kgs, and the third 6, and fourth 9. Here the capacity of the bag is 15. So here we are going to calculate this knapsack problem, solve the knapsack problem using FIFO branch and bound technique. For any branch and bound technique, the root node starts with 1. This node is known as E node. E node means expanded node. So the node is expanded further or not expanded is fully depends upon the upper bound value. So that here we need to calculate upper bound of 1 and lower bound of 1 first. So here while calculating upper bound, fraction of items are not allowed. So here first item weight is 2 and the capacity of bag is 15. So that the item is placed into the bag. That's why we will earn the profit of 10. And the remaining capacity of the bag becomes 15 minus 2, that is 13. That's why second item is also able to place into the bag, so that we will earn the profit. All of you know that the profits should be converted into the negative values, because this problem deals with branch and bound deals with only minimization problems, but the objective of knapsack problem is to maximization of the profit. So that the bag capacity becomes 13 minus 4, that is 9. And the next item is 6. That's why we are able to place that item so that we will earn the profit of 12. So 9 minus 6, that is 3. And the fourth item weight is 9. But here, while calculating upper bound, fractional values are not allowed. That's why we are not able to place the fractional part of the fourth item. So that the total upper bound of first node is minus 32. So this is upper bound of 1 minus 32. Same way we are going to calculate lower bound of 1, that is minus 10, minus 10, minus 12. And here fractionals are allowed to place into the bag, so that fraction of last item, that means among 3 cages we are able to place, among 9 cages we are able to place 3 cages, so that the corresponding profit is earned by us. So the value of this one is minus 38. So lower bound of 1 is equal to minus 38. Okay. Whenever upper bound, the child nodes are generated only if upper bound of the E node is less than or equal to upper bound of 1. Upper bound of 1. So at first time we are not going to compare, so that E node becomes expanded node and it will generate 2 children, that is 2 and 3. That is 2 and 3. In next stage 2 becomes E node. While calculating upper bound and lower bound, all the left subtree becomes by considering the first item should be taken, and the right node right subtree becomes by considering the first item will not be taken into the calculation. So here next E node is 2. So we need to calculate upper bound of 2. While calculating upper bound of 2, it is the leftmost subtree. That's why the first item should be considered. So the first item is minus 10, that is the profit. Second item is also we are able to place, and third item is also we are able to place. That's why minus 32 is there. Okay. Next one, lower bound of 2 we are going to consider the same value we will obtain as first one, that is minus 38. So this is the calculation of lower bound. So here upper bound of 2 is minus 32 and lower bound is equal to minus 38. Okay. Whenever this upper bound is less than or equal to upper bound of 1, then only the node becomes generates the children. So here minus 32, which is less than or equal to upper bound of 1, that is minus 32. That's why this node is expanded and it will generate 2 children, that is 4 and 5. Okay. So here we will follow the Fifo branch and bound technique. That's why next we will move towards right and to check whether the 3 is going to be expanded or not. For that purpose, we need to calculate upper bound of 3 and lower bound of 3. So here While calculating upper bound of 3, the tree becomes right side. So we should not take the first item. So starts with second item. So second item is going to be placed first. So that's why the weight of the bag is reduced by 4 kgs. Bag capacity becomes 11. And the second item weight is minus 12. That's why the bag capacity becomes 5 kgs. We are not able to place the item into the bag. So that is minus 22. So here upper bound of 3, we are going to check whether it is less than or equal to upper bound of 1 or not. So here minus 22 is greater than upper bound of 1. So that's why we need not calculate further and this node becomes dead node. This node becomes dead node. That is minus 22. Okay. So this is the calculation part of calculating 1, 2, 3 and again nodes. Then we will move down and here this level is meant for second item. So here x is equal to 2, sorry, x2 is equal to 1 and x2 is equal to 0. So that means while traverse towards this path, x1 should be included and x2 should not be included. While traverse towards this path, x1 and x2 should be included and the other items may or may not be included. So here we are going to calculate upper bound and lower bound for 4. So here upper bound of 4, what is that one? First item should be included and the second one is also should be included. So here first item minus 10, second item minus 10 and the third item minus 12. That is minus 32. Same way lower bound of 4, first item should be included, second should be included, third you are able to place and some fraction of fourth item we are able to place. That's why we will get minus 38. So here upper bound of 4, that is less than or equal to upper bound of 1. So that's why this node will be expanded. So upper bound of 4 is minus 22 and lower, sorry, minus 32 and lower bound is minus 38. Whenever this upper bound of 4 less than or equals to upper bound of 1, then the node will be expanded and it generates two children. So 6 and 7 are going to be generated. 6 and 7 are going to be generated. One minute, please. Six and 7. So here two more children, that is 6 and 7 are going to be generated. After that we will check whether 5 is going to be expanded or not. For that purpose we are going to calculate upper bound of 5. This is the path. Here first item should be included and second item should not be included. That's why the first item profit is minus 10 and the capacity of the bag becomes 13. So here the second item we are not going to be placed. Why? Because second item is 0. So that's why directly we will move to third item. So minus 12 we will earn the profit. So capacity of the bag becomes minus 6. That's why third item we will not place. Minus 22 is there. So whenever this one is to check whether this is less than or equal to upper bound of 1 or not. Because of upper bound of 5 is greater than upper bound of 1, so that you will decide it as dead node. That means this node is going to be should not be expanded. So this level regards third item. So while traverse towards this path, x3 should be included. While traverse this path, x3 should not be included. So check whether x3 or x3 is included or x3 is not included. For that purpose, calculate upper bound and lower bound for these two nodes. So first I am going to calculate upper bound of 6. Check the path. Here, first, second, third. These three items should be included. So that's why the upper bound value is minus 32. And the lower bound value is same, minus 10, minus 10, minus 12, minus 3 by 9 into 18. That is minus 38. So here this upper bound of 6 is less than or equal to upper bound of 1. That's why this path is going to be expanded 8, 9, and this one is regards whether x4 is equal to 1 or x4 is equal to 0. So this is this path. Next we will consider the values of upper bound of 7 first. While calculating upper bound of 7, first and second items should be considered and x3 should not be used. So first two items minus 10, and the capacity of the bag becomes, what is the capacity of the bag? Whenever the first item is included, minus 5 minus 2, that is 13. And the second item is inserted, 13 minus 4, that becomes 9. So we are able to place the third item into the bag. The value of third item profit is minus 38. Minus 38. So which is less than or equal to upper bound of 1. So that's why you need to calculate lower bound of 7 also. So while calculating this lower bound, minus 10 and minus 18. Why? Because here we will not consider the third item. That's why third item is not going to be placed into the bag, and lower bound and upper bound are equal to this 7. So these are the 11. While calculating this one, x4 is equal to 1, x4 is equal to 0. So upper bound of 7 is equal to minus 38. Both upper bound and lower bound becomes minus 38 here. So next we will check what the node is going to be, which node is going to be expanded here. So here we need to calculate x8, x9, x10, 11 upper bounds. First we need to calculate the upper bound so that the value will obtain whether it is possible to expand or not. This is the last path. So that's why this is the last step. So here first we will calculate upper bound of 8. Upper bound of 8. So that is upper bound of 8. So here along this path, all the 4 items should be taken. x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, and x4 is equal to 1. So all of these 4 values should be taken. So here whenever we place first 3 items, the fourth item is not able to place. Why? Because while calculating upper node, fractionals are not allowed and the bag capacity is insufficient to place the fourth item. So this node becomes infeasible node. Infeasible node. What is the difference between infeasible node and dead node is, here the condition, the constraint is satisfied, that is upper bound of 8 is less than or equal to upper bound of 1, but it reaches the capacity of the bag. That's why we are not able to place that all the items which will shown in the path. That's why this node becomes infeasible node. Here 8 is declared as infeasible node. Next we need to calculate upper bound of 9. So once you are going to check along with this path, x1 should be taken, x2 should be taken, x3 should be taken, but x4 should not be taken. So that's why minus 10, minus 10, minus 12, that is minus 32. So which is less than or equal to upper bound of 1. That's why lower bound of 9 is also going to be calculated, and this value is the same value, that is so fourth item should not be taken. That's why we will not consider the fractionals also. Here lower bound of 9 and upper bound of 9, both of these two are minus 32 only. So next we need to calculate upper bound of 10. So once again it will check, 1 should be taken, 2 should be taken, 3 should not take, and 4 will be taken. So minus 10, minus 10, and x3 should not be taken along this path. That's why x4 directly we will consider. So minus 38 we will get here. So this value is also less than or equal to upper bound of 1. So we need to calculate lower bound, that is minus 10, minus 10, minus 18, that is minus 38. Here also both of lower bound and upper bound should be equal, that will be minus 38. So last, first item, second item should be taken, third, fourth will not consider. So upper bound of 11 is equal to only first and second items we are going to be considered, third, fourth will not consider. So that's why minus 20 is the profit of the 11th node. So here which is compared with the upper bound of 1, and it is greater than this one. The condition fails, that's why this node becomes dead node. And all the 4 items, the decision regarding all the 4 items are taken here. This is x1 1, x2 2, here x3 1, x4 0. This is one path. So 1 1 1 0. This is one path, and another path is 1 1 0 1. This is another path. So here two answers are there, but the maximum profit is obtained by considering this one. So by considering this one. Why? Because minus 32, minus 38 here. Here minus 32 is the value. Here this value is minus 38. Whenever these values are converted into the positive values, plus 38 is greater than 32. That's why this path becomes answer node path. Answer node path. And this node we will declare as dead node, because it satisfies the condition but it obtains minimum profit. The objective function is maximum profit. That's why the answer node becomes this one, and the answer is x1 is equal to 1, and x2 is equal to 1, and x3 is equal to 0, x4 is equal to 1. So that the total profit, Here we are going to consider x1 completely, that is 10. We will obtain the profit 10. And x2 we will obtain the profit again 10, that is 10 plus 10, 20 is the total profit. Third item we are not going to be considered, that is nil. And fourth item we will completely place into the bag. 10, 10, 30, 30 plus 18. Sorry, 10, 10, 20, 20 plus 18, that is 38. Total profit we will get is 38. And once again, for the purpose of cross verification, check the weight, total weight, whether it crosses the bag capacity or not, we are going to check. Here first item is 2, second item is 4, 2 plus 4, 6, and the third item we will not consider, fourth item is 9. So 9 plus 6, that is 15. So here constraint is not violated, that's why the final answer it will become x1 is equal to 1, x2 is equal to 1, x3 is equal to 0, and x4 is equal to 1. So that the profit is 38. Okay. Thank you.